Hey everybody, welcome to part 1 of 2 of 8.3 multiplying and dividing rational functions. So in here we're going to simplify, multiply, and divide rational functions, and by doing that we're going to be doing a lot of factoring. So we're going to take expressions or equations that look like this and then we'll factor it into something that looks like this. So before we get started, I want to just point out avoid the common error, and that is, what I mean by that is, don't cancel out things just because you see like common terms. See this example of x minus 5 over x minus 2, the x's wouldn't cancel out. Pretend that this is saying x minus 5 and x minus 2. They're one statement. It's an expression over a different expression. So unless they're the exact same, they wouldn't cancel out. Same thing for here. The x's wouldn't cancel out. If you want to think of it like this, any number I plug in for x, when I add 3 and then divide it by whatever I plug in for x, it should equal 3. If you're telling me the x's cancel out, it should equal 3 every time. So let's look at an example. Let's just say x equals 6. I'll just plug in 6 for x real quick. 6 plus 3, we know that's 9. 9 over 6 is, what is that, 1.5? That doesn't equal 3. You see what I mean? So it should be that any number you plug in for x, it would always equal 3 if you were telling me that the x's cancel, but they don't cancel, okay? So the times where they do cancel, so this is confusing, you just scratch it out. If they do cancel, they'll be exactly the same. I have an x minus 2 on top and on bottom, so I can cancel it out. So I could say x plus 3 is the simplified answer. Now we are going to talk about some restricted domains here, and on this I'd say the answer is x plus 3 where x can't equal 2. And so we'll talk about that as to why that is. Basically, if you're simplifying this function, you can't plug in 2 here, or else you'd get a 0. So if you originally can't plug in a 2 here, and you're trying to simplify it, well, I could plug in a 2 here. 2 plus 3 is 5. You could grab 5. There's no division going on here. But if you want this graph to output all the same values as this graph does, then you want to restrict your domain so that you can't plug in 2. That's basically the long explanation for it. The short explanation is whatever you see on the bottom of the fraction, you need to write down where the domain is restricted before you start canceling anything out. So let me show you what I mean with a new example. So x squared minus 4x minus 12 over x squared minus 4. So here we have a trinomial that can factor. So I'm going to take this. What are my factors of negative 12 that add to negative 4? That would be negative 6 and 2. Negative 6 and 2. Negative 6 plus 4 plus 2 is negative 4. And negative 6 times 2 is negative 12. So I'm going to say x minus 6 times x plus 2. And then this on the bottom here, what am I going to do with that? Well, that is a difference of squares pattern because you have x squared, that's a perfect square, and then you have minus 4, and 4 is a perfect square. Okay, so I'll say difference of squares right here, and that difference of squares pattern, all you have to do is what's the square root of x squared and what's the square root of 4? Square root of x squared is x, square root of 4 is 2. So you're going to say 1's plus, 1's minus. And so here we see that our plus 2's are going to cancel. But before we do that, we want to write down where the domain is restricted. The domain's restricted at negative 2. If I plugged in a negative 2 here, that would make 0, and that would multiply to get 0. And then x also can't equal positive 2. Because if I plugged in a positive 2, right here, that would make that go to 0. So it doesn't matter what cancels. Write down where your domain is, write down where it's restricted before you cancel things out. Because like I said, it's supposed to be that whatever x values you plug into your new answer, let's write it down by the way, I'm kind of getting ahead of myself. So our new answer would be f of x equals x minus 6 over x minus 2, where x can equal -2 or +2. And so, like I said before, this graph is going to be exactly the same as this, because this is just factored. Now this graph will look different than these two graphs, but it'll have the same y values where you have the x values. So, if x is 10 and y is, 10 minus 4, 6 is 4, 10 minus 2 is 8. So that's 1/2. So if it says x is 10 and y is 1/2, in this original, it'll say x is 10, y is 1/2 here, or in this one there. So all the output values are going to be the same. The only thing is, in this function, you would get an undefined value if you plugged in -2 or +2. And I know in this function, you would get an undefined value only if you plugged in 2. So you have to take into account that the other undefined values for the original before you started canceling things out in order for them to be equal, mathematically speaking. Okay, so that's the long version again. Short version, just write down where your domain is restricted before you start canceling things out. So let's look at the second example. Here we have factors of -12 that add to -1. That would be 4 and 3, and I'm going to make the 4 negative. And then I have another difference of squares right here. So I'm going to say x minus 4 over x plus 3 over, and then the square root of 9 is 3, so I'll say x plus 3, x minus 3. And so my domain is restricted at 3 and -3, so x can equal plus or minus 3. And then the final answer is where the plus 3's cancel out, and I say that f of x equals x minus 4 over x minus 3. Okay? And that's it for that one. So if you feel like you're getting the hang of it, why don't you try this one on your own? There's no difference of squares one. You got two trinomials on top of one another. Okay, so I factored the top. The factors of -3 that add to -2 are -3 and 1, so x minus 3, x plus 1. The factors of -6 that add to -1 are -3 and 2, so x minus 3 over x plus 2. So the domain's restricted at +3 and -2, but the x minus 3's cancel out, so I have x plus 1 over x plus 2. Okay, so now let's just move our attention to multiplying rational expressions. So here with these, we're going to try and simplify things and cancel things out before we multiply them, or while we multiply them rather. So let's just start with a simple example. When you're multiplying fractions, multiply straight across. The only time you cross multiply fractions is when you have a proportion. And a proportion is where you have a fraction equals another fraction. So unless there's an equal sign in between them, don't cross multiply, just multiply straight across. So 8 times 7 is 56. And then add your exponents. X to the third times x to the fourth is 3 plus 4, that's 7. Y to the first times y to the third, 1 plus 3 is 4. Over 2 times 4 is 8. You have an x not multiplying times anything, but y squared times y is y to the third. So at this point, I want you to identify where the asymptotes are. And so it's just multiplying on the bottom. So you can't multiply by 0. If you did, everything would go to 0 on the bottom. So I'm going to say x can equal 0 and y can equal 0. And then as far as my function answer goes, well, let's just divide. What's 56 over 8? That makes 7. Subtract your exponents now. If you add them while you're multiplying like bases, subtract them when you're dividing with like bases. So 7 minus 1 is 6, and 4 minus 3 is 1. So f of x equals 7x to the 6 times y, where x can equal 0 or y can equal 0, okay? So in this example, you have a bit more going on. So what we're going to do is we're going to have to factor this. We're going to have to factor this. And we're going to have to factor this. But that 3x on the bottom is fine because it's just a 3x. So let's start with that 3x minus 3x squared. What I want to do is I want to rewrite it. And I'm going to rewrite it as negative 3x squared plus 3x. And that way it's, in order. It's like in standard form, I guess, is what you'd call it. But I like to have the highest power first. So you see there's a negative 3x squared in front, and then there's a 3x behind it. So you can factor out 3x from both. But since the leading term is negative, I like to factor out the negative as well. So I'm going to divide each term by negative 3x. So that'll just leave me behind with an x here. And then that'll just cancel out. So anything divided by itself is 1. So it's going to say x minus 1 because I'm dividing it by negative 3x. The positive 3x divided by negative 3x will leave behind negative 1. So the bottom one, what are my factors of negative 5 that add to 4? Well, there's the only two factors of negative 5 are 5 and 1. Which one's got to be negative if it adds to a positive 4? And that will be positive 5, negative 1. Okay? And then I'm going to multiply by, well, let's see here. You got x squared plus x minus 20. So what are your factors of negative 20 that add to 1? 5 and 4 are 1 apart. So 5 minus 4 makes 1. So I'll say x plus 5, x minus 4. And then on the bottom, we just had that 3x. Okay? So let's write down where our domain is restricted. It's restricted at 3 places. Can't plug in a negative 5, can't plug in a positive 1, and can't plug in a 0. So that's what I'll write down, negative 5, 1, and 0. Now let's see what cancels. We have x minus 1 cancels. We have x plus 5 cancels. We have, did the x minus 4's cancel? No, but the 3x's do, except it leaves behind a negative. So our answer is f of x equals negative x minus 4. And if you want to go ahead and distribute that, you can. I'd also accept that it equals negative x plus 4. All right? But where x can't equal negative 5, 1, and 0, okay? So let's turn our attention to one more example. All right, so this one, there's only one thing to factor, and that's this expression on the bottom right here on the denominator. So what is that? You have x to the third minus 27. If that looks familiar, it's because we went over in chapter 5, section 4, and that is a difference of 2 cubes. So you'll recall the difference of 2 cubes pattern is that you take your two terms and you write them as literally a difference of 2 cubes. So the cube root of 27 is 3. So I'm going to say x to the third minus 3 to the third. And you have your a and your b, and you'll plug it into that difference of cubes formula. Like I said, it's in the 5.4 notes if you want to go back and watch that video. But lucky for you, I have the formula memorized. So really, it's just going to say a minus b. So I'll say x minus 3 times, and then it'll say a squared plus ab, sorry. So plus 3x, and then plus b squared. So that would be 3 squared, and that's 9. And so if you look, it should look pretty familiar because this is part of that. So we're going to have some stuff that cancels out. Go figure, right? So let's write how it's going to look when I have that factored. Okay, so I basically just rewrote this into this, and then I just threw this over 1. Now, when we multiply, this will be on top, and it'll cancel with that. So our final answer here is going to be f of x equals x plus 2 over x minus 3 times 1, so that's just x minus 3. And then where was the domain restricted originally? It was just restricted where x can't equal 3. That's because this right here doesn't have any additional zeros, so That kind of makes it easier. And yeah, this would be my final answer. Okay? So what I'd like for you to do now is I'd like for you to try these 3 examples on your own. Okay, so for this one, multiplying straight across got me 54x to the 7th y to the 3rd over 6x y to the 4th. When you're subtracting exponents, don't write the negative exponents, just leave the remainder where it is. You see I have 1 extra y, and that's on the bottom, so the y is going to stay on the bottom. Okay, I'm not going to write y to the negative 1 on top. That's technically considered improper in the field of mathematics. So yeah, that's my answer on that one. Let's look at the next one. Here, it's really similar to the one that was before it. I rewrote this as negative 5x squared plus 5x. I factored out a negative 5x, left me with x minus 1. Factors of 3 that add to negative 4 are negative 3, negative 1. The factors of 6 that add to negative 5 are negative 3, negative 2. So when it multiplies straight across, you could just keep it separated and have the multiplying sign. It really doesn't matter. So notice how I wrote everything as one fraction, because technically that's what's happening anyway. Everything would cancel out except for this negative and the minus 2. So that gives me negative times x minus 2, which is the same thing as negative x plus 2. And don't forget to restrict your domain. X can't equal 3 here, x can't equal 1 there, and x can't equal 0 there. Okay? And the third one is a sum of 2 cubes pattern. So that is going to be x to the third plus 2 to the third. And that turns into x plus 2 times x squared minus 2x plus 4. So multiplying across gets me x minus 7 over x minus 7 times x squared minus 2x plus 4 over x plus 2 times all that. So these cancel out. And like I said before, this actually doesn't make a 0 on the other one. And it didn't make a 0 on this one as well. So the only place it's restricted is at negative 2. And yeah, final answer, x minus 7 over x plus 2. So thanks for watching. Stay tuned for part 2. And goodbye, everyone.